You can buy the most expensive MIG welder on the market. You can use premium welding wire. You can spend years mastering your welding technique. And yet, your welds can still end up weak, porous, messy, and full of spatter. Why? Because one of the most important parts of MIG welding is often overlooked: the gas. In fact, choosing the wrong shielding gas can completely change how your weld looks, how deep it penetrates, how much cleanup you'll need afterward, and even whether the weld passes inspection. Many beginners spend hours adjusting voltage, wire speed, and amperage without realizing that the real problem is flowing through the gas nozzle. The truth is, shielding gas is far more than just an invisible cloud surrounding the weld. It's the silent protector of every successful MIG weld. It determines arc stability, it influences penetration, it controls spatter, it affects productivity, and in modern manufacturing environments, selecting the right shielding gas can save thousands of dollars in labor and material costs. So, what are the different types of MIG welding gases? Which one works best for steel? Which gas should you use for aluminum? Is pure CO₂ still worth using? And why are advanced manufacturers now using specialized gas blends to improve productivity and weld quality? In today's video, we're diving deep into the 4 main types of MIG welding gas, how they work, their advantages and disadvantages, and most importantly, how to choose the best one for your specific welding project. Let's get started. Why shielding gas matters in MIG welding. Before discussing the different gas types, it's important to understand why shielding gas exists in the first place. During MIG welding, an electric arc melts both the welding wire and the base metal. This creates a molten weld pool that is extremely vulnerable to contamination. The atmosphere around us contains oxygen, nitrogen, hydrogen, moisture, and various airborne contaminants. If these gases come into contact with the molten weld pool, they can cause porosity, cracking, weak welds, poor appearance, and reduced strength. This is where shielding gas comes in. As gas flows through the MIG gun nozzle, it creates a protective envelope around the weld area. This shield prevents contamination and helps ensure a strong and clean weld. Without proper shielding gas, even a skilled welder can struggle to achieve acceptable results.
The evolution of MIG welding gas technology. When MIG welding was first introduced, shielding gas options were relatively limited. Today, however, welding gas technology has become highly advanced. Modern manufacturers carefully engineer gas mixtures to optimize arc stability, penetration, travel speed, weld appearance, productivity, and cost efficiency. Many automated welding systems now use gas monitoring sensors that continuously measure gas flow and composition. Some Industry 4.0 welding systems can even detect gas supply issues and alert operators before weld quality suffers. Artificial intelligence is beginning to play a role as well. Advanced robotic welding cells can automatically adjust welding parameters based on gas composition to maintain consistent weld quality. As welding technology evolves, shielding gas remains one of the most critical factors in achieving superior results. The 4 main types of MIG welding. Let's examine the 4 most common shielding gases used in MIG welding. 1. Argon. Argon is the most widely used shielding gas in modern MIG welding. It is an inert gas, meaning it does not react chemically with the molten weld pool. This stability provides several important advantages. Argon creates smooth arc characteristics, excellent arc stability, minimal spatter, attractive weld appearance, and better puddle control. Argon-rich mixtures are often preferred by fabricators who prioritize weld quality and appearance. One of the most common mixtures is 75% argon, 25% CO₂. This blend is commonly known as C25 gas. For many welders, it represents the perfect balance between performance and cost. Argon is also essential when welding non-ferrous metals. If you're welding aluminum, magnesium, titanium, or silver, you'll typically need 100% argon. These metals require a highly stable and contamination-free welding environment. Why modern manufacturers love argon. Today's robotic welding systems often rely heavily on argon-rich mixtures. The stable arc allows automated equipment to maintain consistent weld quality across thousands of parts. This consistency is critical in industries such as automotive manufacturing, aerospace production, and precision fabrication. Argon has become the backbone of modern automated welding operations. 2. Carbon dioxide, or CO₂. Carbon dioxide is one of the oldest and most economical shielding gases used in MIG welding. Unlike argon, CO₂ is considered semi-inert. This means it reacts somewhat during the welding process. Despite this characteristic, it remains extremely popular. Why? Because CO₂ provides exceptionally deep penetration. This makes it highly effective for welding mild steel, structural steel, and heavy fabrication components. One major advantage of pure CO₂ is cost. Compared to argon, carbon dioxide is significantly less expensive. For shops focused on productivity and budget control, this can be very attractive. The downside of pure CO₂. Nothing comes without trade-offs. While CO₂ offers deep penetration, it also creates more spatter, a harsher arc, increased cleanup, and less attractive weld appearance. Many welders describe pure CO₂ as aggressive compared to argon-rich mixtures. It gets the job done, but it often requires more post-weld finishing. This is why many modern fabrication shops have moved toward blended gases rather than pure CO₂. 3. Helium. Unlike argon, helium produces a much hotter arc. This increased heat offers several advantages. Helium provides deeper penetration, faster travel speeds, higher productivity, and improved fusion on thick materials. For heavy section materials, helium can dramatically improve welding efficiency. Common helium mixtures often contain 25% to 75% helium combined with argon. The exact ratio depends on the application.
Where helium excels. Helium is frequently used when welding thick aluminum, stainless steel, copper alloys, nickel alloys. Its hotter arc makes it particularly useful when maximum penetration is required. The challenge with helium. The biggest disadvantage is cost. Helium is considerably more expensive than argon or carbon dioxide. It also requires higher flow rates because it is lighter than air. For many small shops, the productivity gains may not justify the increased expense. Large industrial manufacturers, however, often find the investment worthwhile. 4. Oxygen. Many people are surprised to learn that oxygen is sometimes added to MIG shielding gas. After all, oxygen is usually considered the enemy of welding. In small amounts, however, oxygen can be highly beneficial. Typically, oxygen is added in concentrations below 9%. When used correctly, it improves arc stability, weld puddle fluidity, penetration, and wetting action. This helps create smoother, more consistent weld beads. Important limitation of oxygen. Oxygen should never be used with certain metals. It is generally unsuitable for aluminum, magnesium, copper, and reactive non-ferrous metals. These materials are highly susceptible to oxidation. Using oxygen with them can create serious weld defects. For carbon steel and certain stainless steel applications, however, oxygen blends can be extremely effective. Other specialty welding gases. Beyond the 4 primary gases, some specialized applications require additional shielding gases. Hydrogen. Hydrogen is occasionally added to shielding gas mixtures for austenitic stainless steel and high-temperature welding applications. Hydrogen helps improve weld appearance and penetration. However, it must be used carefully because excessive hydrogen can create weld cracking. Nitrogen. Nitrogen is often used in stainless steel welding. It helps maintain corrosion resistance and material properties. Some advanced gas blends include small amounts of nitrogen specifically for high-performance stainless steel applications. Propane. While propane is not commonly used as a shielding gas for MIG welding, it is frequently used for cutting operations in fabrication environments. Its low cost makes it attractive when cut quality is not the primary concern.
Conclusion. When most people think about MIG welding, they focus on the machine, the wire, or the welding technique.
But experienced welders understand that shielding gas is just as important. The right gas can transform a difficult welding job into a smooth, productive operation. Whether you're using argon for aluminum, C25 for mild steel, helium blends for thick materials, or specialty mixtures for stainless steel, every gas has a purpose, every gas has strengths, and every gas affects the final weld in unique ways. Modern welding technology continues to improve, but the fundamentals remain unchanged. Strong welds begin with proper shielding. By understanding how each MIG welding gas behaves, you'll make better decisions, reduce defects, improve productivity, and consistently produce cleaner, stronger, more professional welds. And in the world of welding, that's a skill that never goes out of style.